Welcome to the part 2 of the hardware design tutorial. In the part 2, we will finish the job with the hardware design by exporting the hardware into the SDK. And after that, we will continue with our C code and getting the result from the board. So we'll go back to the Vivado. By this time, the bitstream generation has been completed. As you can see, write bitstream complete. We can go to the diagram and just check something here. You can double click on this processing system. As you can see, by using the default settings, we have also enabled the UART1 and some other peripherals. But the main concern is the UART1, which we are going to use it in the debugger mode on the board to get the results from the C code, and also which can help us to see the result when we are interacting with the buttons. The next step is to press File, Export Hardware. Make sure that this option has been checked. At this point, the hardware will be exported into the SDK. So after that, we will go to the File, Launch SDK, everything on default, and we just wait for the SDK to load. Okay, while the SDK is loading, we can take a look at our C, which we will use in the next part. Here we can see that after defining the main, we have created two instances with the GPIO construct, and then we have two variables to store the value of the buttons and switches, which we will read later. After that we have to initialize the GPIO, and since we used two AXI GPIOs, 0 and 1, if you recall, we use this format, these functions, and then we will set the direction for each of this on each different channels. If you recall, the AXI GPIO 0 had two channels, channel 1 and channel 2, which we put both of them to be input. And for the next one, which is AXI GPIO 1, as output and only has one channel, which will be used as an output. And then the code that will be keep running is here, in which we will read the data from the channel 2 on this GPIO port, and we store it in the switch data. Then in this part, we will write the data into the output, the channel 1, which is this one. And then we have this case, which we implemented with an if-else statement. In case that one of the buttons has been pressed, this message, one of these messages, will be printed out into the terminal, and in case that more than one button was pressed, this message will be sent into the terminal, and there is a delay. Okay, let's copy this code and go to the SDK, which has been launched automatically. Here we can see that this is the system HDF, hardware definition file. This is where everything has been defined for a hardware design, which we are going to use it in our code. Okay, we go here, press application project. Here we will specify a name for our project. I go with the same name as before, LED button switch. keep everything by the default and press next. We go with the hello world, which will generate the necessary libraries and includes for us. Finish. Okay, these two folders has been added to our project. We go to this one and then to the source. Here we can see the hello world, which we are going to change the program, change this code to replace it with our code. There we have it. Okay. After this, we have to connect our ZeBu board to the computer and turn the board on. And we need to make sure that two LEDs, one of them is P good and done, both of them are lights switched on, and in that case we know that the board is functional and everything is fine. And also make sure that the GP5 on your board is set on JTAG. So the next step is to program the FPGA by pressing this button. Keep everything as default, but just in case that your hardware was not detected, you can just make sure that everything is fine by going to auto detect and see this is my device, everything is fine. So okay, the first program. Okay, we have successfully uploaded the program to the FPGA. Now we need to right click on the project folder and then go to the run as. Oh, at this point I can see that there's error in the program, which is this button data and button value. Yeah. So the thing is that here the variables that we defined are called buttons value and switch value, but here we are using button data and also switch data, which is not defined. But it's okay, we are going to run it anyway to see the errors. Actually, this is a good example we can go through the error and see how this SDK, which is basically Eclipse, will show you the errors. Okay, so we go to the run as, launch on hardware. Okay, as you can see, the SDK is showing us that there are some errors, undeclared as we said prior. Okay, problems, undeclared. Excellent. We can easily fix it by using the button value here, and also here. The next one is this guy and this guy. Okay, we forgot this one. And there should be no more errors. Excellent. We run it again. Okay. At this point, if you use any switches on your board, you can see the corresponding LED will be turned on, and if you turn them off, if you turn off the switch, the corresponding LED is also turned off. for the test of buttons, which is here, we need to use a terminal. Let's use the SDK terminal for this one. We can open it. Okay, the port is, for me, is the COM8, but you can just check your hardware manager and check that which one of your COM port is representing the USB UART on your board. And then the baud rate is 1152 Okay. And now, yes, as you can see on here, I'm pressing different buttons, and therefore I'm seeing the result. And if I press more than one button, it will tell us that more than one button was pressed. And this is the last part. This was the last part of the video. I hope you liked it, and thank you for your attention.